Okay, welcome back to our podcast series, Lime Time in Texas. I'm Dale Rand, the Executive Director of the Lime Association of Texas, and today I'm going to be talking about what I call the second key to successful lime stabilization. Previously, I did a presentation on the three main steps, or the three critical steps to ensuring that you have successful lime stabilization. Those three steps were applying the right amount of lime, mixing it to the specified depth, and then using the correct amount of water. Today, I'm just going to focus on mixing to the specified depth and go into a little bit more detail on how to do that properly. So our goal here is to control the mixing depth to meet the specification requirements. Typically, when you see the plans, or our goal here is you want to mix within about a half an inch of the specified depth. So if it says that you need to go 8 inches deep, for example, you at least want to be that 8 plus or minus a half an inch. You want to get as close as you can. In real life, we know that you never get it exactly 8 inches, but the goal is to get as close as you can. It's important to control the mixing depth because that ensures that you have enough lime, a high enough concentration of lime to transform that expansive clay into a pozzolanic cement, which is calcium silicate hydrate or calcium aluminate hydrate. So to make sure that we do that, we've already gone over step one, which was designing, making sure we got the right percentage, calculating how many pounds per square yard that is out on the project, and now we're to the point of mixing it to the right depth to make sure that this is done correctly. If you mess it up at this point, then particularly if you overmix the depth, then you're going to dilute the amount of lime that was needed to really properly stabilize that clay soil. So controlling the mix depth also ensures that there's enough lime to maintain the soil pH, to make sure that it's above 10 throughout the lifetime of the pavement. This really ensures that the silica and alumina that comes from the clay soil, that they remain soluble, and so they're available to react with the calcium and the water to form this calcium silicate hydrate or calcium aluminate hydrate. So how do we control the mixed depth? And contractors, the more experienced a contractor is, the easier this process is, but basically, you're taking these very high horsepower mixers out there and mixing it to the right amount of depth. What I say here is that you need to do control checks, quality control checks very early and very often to make sure that you're within reasonable compliance of that specified depth. So in this presentation, I'm going to use the example that we're shooting for like 8 inches of depth. Let's just pretend that's what was specified. So then what you can do is use phenolphthalein to verify that mixed depth is correct. And so we do that at the very end of this process to measure, and when it turns the phenolphthalein turns pink, we know that has lime in it, and if you can measure the depth of that, that'll tell you what depth that you mixed it to. So one of the critical things to remember here is that the mixer is very heavy. Particularly these modern day mixers that are very high horsepower, they do a great job of mixing. And I'll show some pictures in a minute of how efficiently they're able to mix that. But as they fluff up that lime, one of the things that happens is they tend to sink a little bit. And then the other thing that we see tends to happen is human nature is that if you tell me to go do something, mix this 8 inches deep, the tendency is, well, I want to make sure that I get at least 8 inches deep, and more often than not, somebody will go a little too deep rather than go too shallow. So, and with lime, it's more important that you not overmix that depth. So if you go too shallow, that's pretty easy to fix. I'll go into detail how to do that in a minute. But if you go too deep, then you can have some issues. So the other thing is that you don't want to scarify that. So typically when you're adding, you don't want to scarify the existing subgrade too deep before you add the lime. So the example here, I say if you're going to mix it 8 inches deep, you want to only scarify maybe 4 inches deep to just kind of rough that surface up so that when you put the lime or the lime slurry, whichever you're using, a quick lime or lime slurry, either one, it's going to go down into the valleys of that scarification. So you don't want to scarify that 8 inches deep, because when you get that well mixed in there, you're going to end up at 10 or 12 inches deep. So we typically want to only scarify it at maybe half the depth that you're at the most of how deep you're going to mix it. And then once you start mixing, you can check that depth and keep mixing until you get it to the proper depth. So I just say here that if you scarify at 8 inches, that allows much of the lime to go too deep, resulting in over mixing that depth and basically diluting that amount of lime. So that's what we want to avoid in this case. So this is just a picture showing that where lime slurry has been added. So if we go back to review the previous presentations, we know that we're trying to use 6% lime because that's what was done in the design using the Eads-Grimm test procedure, which is 121E Part 3. We know how far we're going to spread that out because we know how many tons of lime was on that truck. So I'm going to just use an example here. The truck shows up and it says we have 10 tons of lime on this truck. So you can measure out how many square yards that's going to cover. And so you mark that out and you tell that truck driver, I need you to go from here to here and mix that lime in there uniformly. They do a very good job of offloading that lime. All they need to know is what area you're going to cover with that and your rate. So we've done all of that correctly up until this point. So now the next step is just mixing that. Now, notice here, this is not scarified very deeply, but I have seen sometimes where they come in and try to scarify too deep before they add that lime slurry on there, or quicklime, either one. So the process that's going to happen, the lime soil reaction, is you're taking this heavy fat clay that looks like a big clod here that's not desirable to use in pavement construction or really any kind of construction. You're mixing the lime in there with it, and this one shows where they've roughed up the surface, scarified it some there. They've got the lime slurry that they're adding in there. When you put this mixer on there, you can see immediately as it makes its first pass through there how much it's fluffing up that lime or fluffing up that soil. So it's immediately reacting with that soil. You're getting some breakdown in the plasticity index, and you're getting some flocculation of the soil particles there. But this tells you that everything's working correctly if it starts fluffing up like that. But what you do want to, what I mentioned earlier, you want to be a little bit careful is that as that fluffs up and this machine will tend to settle, you don't want to end up shooting for 8 inches and end up with 12 inches. So ultimately at the end we want a soil that looks like this. It looks more like a sandy, granular soil. It should be very workable in your hand at that point. And that way we know that we've done a good job. So we've got the cation exchange happens immediately. The flocculation and agglomeration happens. And now the third step of this is the pozzolanic reaction. The pozzolanic reaction happens over months, weeks, years, decades. Once you get it to this point and you've got the right amount of lime in there. If you get it over diluted and you don't get the right amount of lime, then you're never going to get this third step, which is the pozzolanic reaction that's really critical to fully stabilize the clay soil. Here's just a couple of more pictures of that same project. This was in San Antonio. Again, you can just see how much it's fluffing up and use the track marks that you see in there. This is just a very typical operation. We'll talk a little bit about how to correct issues if you get the mixed depth wrong. And then I'll go back to showing you how you measure that mixed depth. But if you get the mixed depth too shallow, let's say that you're shooting for 8 inches and at the end of the mellowing period and the remixing period, you went in there and you measure it and you can see that phenolphthalein only goes down 6 inches, it only turns pink 6 inches deep, and you need to mix it 2 more inches. You can just simply go back in, adjust the mixer to go down another 2 inches and remix it. There's nothing wrong with doing that at all. So if you mess up on the shallow side, and again, it's just very easy to go back and correct, and the lime will continue to work just as intended. But if you mix it too deep, then you've got a little bit of a problem. So, because the concentration of that lime is too, you've reduced the concentration of it. So that thicker layer, you'll never really truly get that lime layer stabilized. So you'll have it modified. You'll get a lot of the good benefits out of it, but you'll never reach the point of actually getting it stabilized. So you'll have a modified soil, but not a stabilized soil. And so, because you never really triggered the chemical reaction of forming the CSH and the CAH, that is the calcium silicate hydrate, calcium aluminate hydrate that you need to form the pozzolanic cement. So to remedy this problem, if you get it too diluted, is basically go back and add more lime. So you can go into the lime calculator, and I won't really go into that right now, but you can go into the lime calculator and put in for example here, we used 6% lime and we were trying to go 8 inches deep, and let's say we went 10 or 12 inches deep, if I go in and plug 12 inches deep in there into that lime calculator, it'll tell you how many pounds per square yards I needed to be to go 12 inches. You can take the difference between that and what you should have done at 8 inches, and it'll tell you how much additional lime that you're going to need. And that you simply just go add that additional lime to that and remix it again, and then you fix the problem. So it's not the end of the world. If you overmix it, it's going to cost you more money. And to get it truly stabilized, as long as you don't ignore the problem. Now, if you ignore the problem again, you're never going to get stabilization more than likely, because you're just not going to have high enough lime concentration in there to achieve the goal of reaching a pozzolanic cement. But here's a couple of pictures of how you're going to check to make sure that you're getting enough lime in there, or not that you're getting enough lime, but you're getting it to the proper depth. Now, this is not a real good picture. This is just showing how wide the lime was used. So this is not measuring depth, but they've sprayed phenolphthalein across here to see that they've already mixed it this far out to this point, so they can spray and see that they have that there is a presence of lime. But to measure how deep it is, you typically, this is just showing an example, and it's again, it's not real easy to see in this photo here, but you can measure how deep that phenolphthalein turns color in there. I think I've got one other one. This is a little different picture. Again, this shows the presence of lime, and if you measure down in there, hopefully that bottom 8 inches, you should be able to spray up the face of that, and for the bottom 8 inches should be, that would tell you that yes, we got that right amount of lime in there, that we mixed it to the proper depth. So this is just showing one that they've already put the base on top of, and they're trying to measure down and look to see, for the presence of lime or how thick it was in there. So that's the general process, is just making sure you got the right amount of lime. Step 2 of that was making sure you mix it to the proper depth to ensure that you're going to get that pozzolanic cement over time. So hopefully you've learned a little bit about how to mix to the proper depth, and if you have any questions, feel free to call me. I've got a third part to this series. It's going to be making sure you got enough water, but that's all we have for today. So I appreciate your time. Thank you. Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn and subscribe to our YouTube channel. Thank you for watching.